Hello, my name is Kyrstin Scott, and I am a student at Arizona State University attending the SES141 Energy and Everyday Life course. This is my video of how to create a lemon battery. I want to make sure that everyone can see the counter and what I'm doing, so the camera is a little aimed down. You're going to be able to see like maybe half of my face, but I just wanted to show you all how my interpretation of how to do this. So I have the instructions here on my phone. Okay, so in order to make a lemon battery, you're going to have at least one lemon, but this assignment calls for making more than one battery, so I have two. And then you're going to need 2 pennies, but also I looked in the extras in the questions portion, and it states that you're going to have to try to use different types of, maybe like a different like fruit or different vegetable, or use like a different coin. So I have my 2 pennies, and I also have nickels here as well. It says that you're supposed to wash them. I have my aluminum foil, and I have 2 plastic coated paper clips. And in case you don't know what that looks like, it's the colorful ones. So it says after you wash the pennies, you need to cut 3 aluminum foil rectangles, each 3 by 20 centimeters. So you, of course, doesn't have to be perfect, but I'm going to just estimate what 3 by 20 centimeters is for one. And just cut that. These might be way too big, or they might be too small, but this is just my estimate of how it should look. Oh, my computer's asleep. Okay. And it says after you do that, to fold each strip in thirds lengthwise to make 3 sturdy 1 by 20 centimeter aluminum strips. Okay, so you're going to fold them. And it's saying for the third battery that you don't need 2 strips for the third one. You only need 1. So that's why it has you cut 3. So this is my first strip. I just folded it in thirds. Like I said, it doesn't have to be perfect. So you just take it and you fold it over itself. It's my second one. I think that's all the aluminum foil I needed. I cut way too much, but it's fine. And this is my third strip. All right. So the next step says to roll the lemon gently on the table to break the cell walls and loosen up the juice inside. So you're going to just roll it gently, obviously, and do that to the other one as well. Well, I can't hear that. I hear it breaking. Okay. So then it says to make a small cut near the middle of the lemon, about 2 centimeters long and 1 centimeter deep, and make a second similar cut about a centimeter away. So I have this little knife here. It's for my incisions. So I'm going to make a cut near the middle, about 2 centimeters long. Ooh, these are really juicy. 1 centimeter deep. And then a second similar cut about a centimeter away. Everybody see this? You can't. If not, sorry, but there's 2 cuts there. You can see that. Okay. And then it says to push a penny in the first cut until part of the penny is in contact with the lemon juice. So I have a penny here, and I'm just gonna take it, push it in like that. Now it's in contact. The juice is actually dripping. So after that, it says slide one of the aluminum strips in the second cut until you are sure part of the aluminum is in contact with the lemon juice. So I'm going to take one of my strips, slide it in. Hopefully it gets in there on its own. I think I might have to open it up, squeeze it the other way to open it up. Get a little, ooh. Looks like it's in there. Yeah, it's in there. It might have to get a little bit deeper than that. Let's see. The aluminum foil is kind of like flimsy, so make sure that your cut's deep enough. Oh, there it is. It's in there now. It's in there. That's what it looks like. Right next to the penny. So then it says, attach the second aluminum strip to the part of the penny sticking out of the lemon with a plastic coated paper clip. So take one of your paper clips, grab another strip, and just attach it. And I'll show you what it looks like close up when I'm through with it. I'm not really sure. Oh, actually, there it is. That's what it looks like so far. With my two strips and my paper clip. Then it says, bring the two aluminum strips into contact. As soon as the two aluminum strips touch one another, electricity will be produced throughout the battery and flow through the strips from one electrode to the other. You cannot see the electricity flowing, but you can try to feel it. Can you feel a tingling created by a small amount of electricity? So let's see if it works. Oh, wow. Oh, wow. I definitely feel that. Wow. It's really subtle, but it's there. I didn't think it, I've seen some people make these and it didn't work for them. But if you touch, you can feel a slight amount if you touch these two together, and if you've done it right, and if the strip is deep enough to touch the lemon juice, and so is the penny, then you can feel it. Wow, I never knew that that was a thing. That's really amazing. And it also says here to create a second battery identical to the first, and you can choose a different spot on the lemon. So what you're going to do is, what I'm going to do rather, is take this one, and I'm going to put it here this time. Ooh, that's a little too deep. These are fresh lemons. And then it says, I'm going to use a nickel this time to see what that does. Choose a different spot. You only need one additional aluminum strip. Use a plastic coated paper clip to connect the aluminum electrode of the first battery to the copper electrode of the second battery. So actually, let's just stick with the penny for this one. Slide that in. Aluminum electrode. Oh, wait. It says the aluminum electrode of the first battery to the copper electrode. Got you. So we're going to have to slide this penny in here. And then we'll see what that does. And then we're going to go and switch and put one of the nickels in and see what that does. So take your paper clip and attach it. And it should create a little chain link, I'm assuming. Although I've never done this before, and I'm not quite sure how it should look. But this is what I came up with. It could be wrong, but we'll see if I feel anything. Put a little slit next to it. Ooh, that tingling from before is crazy. That's crazy. I never knew that that was a thing. All right, so I connected these two lemons. I cut them in different places. And now I'm going to join these two up here at the top to see if I feel anything from that. And I do. Wow, that is so cool. I did not know that that is so cool. Wow. That is so cool. Okay, so let's try it with 1 nickel and 1 penny. Let's take it out of this one and see what happens. Oh, my computer's trying to go to sleep. Ooh, don't rip. Sorry about that noise if you hear it. It's my dog is walking around with his long toenails. But yeah. So see if we can slide this in to this one and see if that makes a difference. Okay, it's in contact with the juice. Now let's see what that does. And I think it would be interesting if I needed to put 1 nickel inside of this one, inside of both of them rather. So let's see what this does. Huh. I don't really feel much. I guess that it's not the same. But as far as the questions go, which material, penny or foil, is the positive and negative electrodes of your battery? I'm going to assume that the positive is going to be the foil and the negatives is going to be the coins. If you have a voltmeter, never heard of that, measure the voltage and the current of your battery. What power is produced by your lemon battery? Now, I remember the lemon battery assignment, and I assumed that it would be a fraction of a decimal of a watt amount of energy that was produced by the lemon battery. So it says how many lemons would it take to equal a car battery? And my best estimate of that would be around 365 million lemon batteries to power a car engine. That's just a rough estimate. I didn't really feel much energy from this, so I would assume that it would take a lot. And now it's talking about different types of metals, which I did try, and different types of fruits and vegetables, which I do not have, so I have not tried. I just had these 2 lemons. And I do not have an LED light emitting diode. Therefore, I guess this is the end of my experiment. Thank you all so much for watching.